All right, honors chemistry people, we are going to do our density lab. So our density lab is found on page 289 in your chemistry manuals. So you will want to rip this out, okay? It's on 4 pages, so you're gonna wanna rip out 289 and 291 so that you have both of those pages. Okay, so this lab, we're going to pay attention to a couple of things. We're going to pay attention to units. We're going to pay attention to significant figures. And we're also going to pay attention to calculations. And the other thing in this lab that you're going to have to do is you're going to have to come up with your own lab procedures for some of this. I've outlined a procedure for the very first part, but for the second, third, and fourth part, you're going to have to come up with your own procedure. So use the first lab procedure for the first part as kind of a guide of what I want written down. Okay, we're going to be using a bunch of different supplies here today. So the first supply the first equipment that we will be using is the balance here. A lot of people will call these scales, but in chemistry we call them balances. So make sure that you call them balances. I do have this plugged in, so we're going to turn this on really quick. You'll notice it takes a while to load up. So let me get here. So here we have our on off, and this is also our 0 button. And this is our print or unit. So we can change our units here. We don't have this hooked up to a computer to print out an actual measurement. So you're going to have to do the writing here. Okay. The other thing that we are going to use is we are going to use some graduated cylinders. This smaller one is a 10 milliliter graduated cylinder. And the lines here, I'm going to put some white paper behind it. The lines here are blue, and those are 0.1 mils. So you can measure to the 0.01 mils by estimating in between those lines. Now, these lines here on this one are red. So let me get something that's a different color, or they're white. So if I put white paper, you're not going to see it. So I'm going to put some red behind there. These lines on the 50, or actually this is a 100 mil cylinder, are each worth 1 milliliter. So you can estimate in between those lines to the 0.1 milliliter. Okay? Any questions on that? You'll notice that putting something behind that's a different color than the lines will help you see the lines better. So you'll see me putting things behind all the time. Okay, so the other thing we're going to use also is a handy ruler. Now, when we use a ruler, we are going to do the metric side. We're going to use the centimeter side. You'll notice that the 0 does not start right at the edge. So make sure that you're using the 0 where the 0 actually is and not the end of the ruler. Okay? And we are going to be using a thermometer as well. So there are thermometers in the back of the room. I'm just going to know that we are at about 69 degrees Fahrenheit in this room. So let me translate that. 69 minus 32 times 5 divided by 9. So that gives us about 20.5 degrees Celsius in here for our temperature. Okay? So let's look at our first one. We're going to do our density of water. We're going to measure the mass of the dry 10 milliliter cylinder. So I'm going to put this dry 10 milliliter cylinder on here. And I'm going to mass this, and I need to have a pen so I can write down the mass. The empty cylinder is at a mass of 30.33 or 30.32. You'll notice that it goes back and forth. So it will usually land on 1. So we're going to use 30.33 for our mass. So I'm going to write down 30.33. Now, for our distilled water, I have these blue squeeze bottles. They squeeze. These are full of distilled water. You're going to want to squeeze this and have the water go along the side so it doesn't create bubbles. You're going to want to put this in here as close to 10 mils as possible. Now, in order to read this, we also need our eye to be right at the same level as the water. So I'm going to kneel down so that my eye is right at the same level of the water so that I can read that meniscus. Remember, water creates this curve in glass. So we always read at the bottom of that curve. So let me get this as close to 10 as I possibly can. Okay, we just need a little bit more. Okay, you will notice that when I put this up here, we do have a bit of a curve. And if I look at that, at the meniscus, I'm right at the 10.00 mark. I could, yeah, right at 10.00 mark. So I'm going to write 10.00 for my volume in the milliliter part. And I'm going to take my mass of the cylinder with the water now. So my mass with the water is 40.18 grams. Okay, so if I look at this, I need to get the mass of the water. The difference between this and this is the water. So if I can subtract this and this, I will get the water. Then I can calculate my density right here. I also just calculated my temperature. My temperature in here is 20.55. So I would be fine if you use 20 degrees Celsius or 21 because we are right in between 20 and 21. So either one, somewhere in there, 20 and 21 are the ones that we would use. So use this formula down here to calculate the percent error. Okay? On to the next procedure. I'm going to probably give you a hint on what we're going to do because you're going to see me doing it. So density of salt solution. We're going to take this. We're going to still use this. We're going to dump it out so that we can use the salt solution. And you'll notice that not all the liquid leaves. So you might want to take it and shake it out a little bit. It's not going to always get all of that water out. And that's okay. We're going to just do what we can. So the first thing we've got to do is we've got to mass that cylinder again. And our original mass is 30.24. So I'm going to write down mass of cylinder. Okay. 30.24 grams. And now I need to get the solution of the salt solution. We're going to use a copper sulfate solution. And the reason I like to use copper sulfate is it's always blue. So it's really easy for you to tell the difference between water, which is colorless and clear, to the copper solution, which is colored blue, but it is still clear. Okay? So we're going to pour this in here, once again, very carefully, trying to get exactly 10 mils without any bubbles. And once again, I want to put some white paper behind here to see where I'm at. And I am right at 10 mils. So I'm going to show that. So if you look, the meniscus is right on that line, 10 mils exactly. So I'm going to take my volume and I'm going to write down my volume. And I have a volume of 10 mils. And then the last thing I need to do is find the mass of the cylinder with the solution. And if I do that, I get a mass of 40.48. Okay, so you should have a mass of your just empty cylinder, mass of the cylinder with the solution, and your volume. And you can get all the calculations that you need for your density off of that. Remember, you also need to give me some procedures. How are you going to go about that? Okay, next we're going to work on the density of a wood block. So to find this, we need our length, we need our width, and we need our height, and we also need our mass. So let's get those done. Okay, so here's my wood block. I'm going to mass this really quick. And when I mass this, I get a mass of 113.16 grams. Okay, now I'm going to measure the length, the width, and the height. So I look at the length. I want to get that 0 right on that edge. I get a length of 14.9 centimeters. I get a width. Let's check out this width. I get a width of 5.95. 5.95, and I get a height of 2.4. Okay, so for this part, you should have your length, your width, or your height, and the mass, and that is enough to figure out the density of the wood block. You are going to have to come up with a procedure as to what we did as well. Okay, on to part D. So part D, we're going to take the density of marbles. So I have some metal marbles here, and we're going to use these. The first thing I want to do, though, is I want to put a weigh boat on here. I don't want to put these metal marbles right on the pan of the balance because they're going to slide around and create a mess. So you'll notice that this is not reading 0 with that weigh boat on there. So what we're going to have to do is we're going to have to zero that out so that we're not weighing the weigh boat, so that we're just weighing the marbles. So I'm going to start putting the marbles in here. Okay, so we have our mass of our marbles of 46.24 grams. So I'm going to write that down. We have our mass of 46.24 grams. Now we've got to figure out the volume. So we're going to use a method called displacement. So I'm going to use this bigger cylinder, and I'm going to put just a little bit of water in here. And then we're going to put the marbles in and see how much the water rises up. And we're going to use the difference in that water to get us the volume. So let me get some water. Okay, so I now have some water. I need to figure out how much water I actually put in here. So I'm going to get my red background because this is white lines, and I want to be able to see those lines really well. So it looks to me like I have 51.5 milliliters of water. So I have 51.5 milliliters of water. I'm going to add these marbles, and I'm going to add them one at a time, and I'm going to really carefully add them. I don't want to just drop them in because that will probably crack the glass. I'm going to tilt this and let these marbles roll down gently because I don't want to crack the glass. I really don't want to splash the water either. Because if I splash the water, that messes up my... So let's see. I've got some bubbles. Let's see if I can get rid of those bubbles. Yes. So let's look at this volume now. My volume has gone up to 56.8, it looks like. So we're going to report that as 56.8. So my cylinder with the marbles is 56.8 milliliters. Okay. So this is the raw data that you're going to need for this. You need to once again come up with a procedure, figure out how to do the calculation for the density. And then your last question is kind of a bonus question, a thought question. Suppose you had an irregular shaped artifact made out of wood and a second irregularly shaped artifact made out of a large crystal that will dissolve in water. How would you find the density of those objects? Give me a thought. Okay, see if you can figure it out. Have a great day, guys, and hopefully you learned something in this lab. We'll see you. Bye.